I want you to recall back to last week, and we started in chapter 2, and we said, hey, linear programming is great because we can apply it to a whole bunch of business applications. We talked about marketing and manufacturing and investing and advertising and agriculture, all those good things. And it's nice because, we have a solution technique. We have solution techniques like Solver, right? We've solved the heck out of it with Solver. But we also said there's some assumptions that we have to make when we do linear programming. I don't know if you guys recall these. We said, here are some of the assumptions. The parameter values are known with certainty. And we said, you know what? In reality, we violate that because we don't know, that we're going to make this much profit for something when we make it. We hope that's what we make. We don't know we're going to make $80 an acre for every acre of corn we plant. We don't know those things, right? But we have to assume that we know those with certainty. So we violate that all the time. Constant returns to scale. We violate that, right? The first item is more expensive to make than the millionth item. We know that, right? That happens all the time in the world business. So we violate that. There are no interactions. We know sometimes there's interactions. You make product A, it might be easier or more difficult to make product B. So sometimes there are interactions between those things. And we use the continuity assumption. A lot of times that is valid, but we make a whole lot of assumptions and we say, we violate those. So how good is this? We have a solution, but we say it's built upon all these assumptions that we violate. So how good is the solution? Well, so far, we've been solving problems, and we've been coming up with an answer. And last week, if you recall, we talked about the space ray and zapper, and we talked about building this, and we came up with a model, and we built something called a feasible region. Remember, we did it with the graphing the lines. We came up with a feasible region, and we said, hey, this is our feasible region, and our optimal profit is the last point that we touch the feasible region. That's our profit, okay? So what we're going to try to answer this week is, now that we have a solution, how good is that solution? We want to do some what-if analysis. We want to say, how robust is that solution? Is it a solution just in this narrow vein of variables? Or is it a solution, even if we're off by like 50% on our profit values, is this still the right mix to make? Does that make sense? So to do that, we need to analyze something called sensitivity analysis. Okay, and this is probably one of the hardest weeks conceptually worth of material. There's a lot of new terminology here. There's some new concepts, but it's really powerful stuff, and it's really helps you show the power of Excel Solver, because not only we get a solution, but we say, hey, this is the solution no matter what. So once we have a solution, what kind of questions as a manager might you ask? Once we have a solution, I tell you, you go to your manager and you tell her, make 360 dozen zappers and 320 dozen space rays, and you'll make this much profit. As a manager, what other questions? What might be your follow-up questions? What might be your follow-up questions? Okay, do it blindly. Another day on the job, punching the clock. Why are you doing that? Because he told me to. A good manager does what, Dan? What?
Maybe ask, how can we be even more efficient?
All right, good. So how can we be more efficient? Like, what's holding me back, yes? Why am I only making $5,000? What am I running out of? Am I running out of plastic? Am I running out of time? And if so, what would it be worth to me to acquire more plastic or more time, right? If I acquire another 10 pounds of plastic at this price, is it worthwhile for me to do that? Or time, is it worthwhile? So that's a good question. That's one thing, yeah, that's a great question. That's something we're going to look into via sensitivity analysis. What's holding me back, and can I acquire more of it, right? And how does it help me? What else? Given the assumption that we made. What else might I want to know? Remember we said, like, a lot of the things we said we know with certainty, like $80 for every acre of corn, $60 for every acre of barley, $8 for every space ray, $5 for every zapper.
sometimes we violate that, right? That's just our guess, right? We think we're going to make that. So we might want to know, hey, this is the right mix. Make this many dozen of this and this many dozen of this. But what's the range that's the right mix? I mean, what if we made $9 per dozen? Is that still the right mix to make? $3.60 and $3.20. What if we made $7? Is that still the right mix? So not only is this a solution, but what is the valid range for this solution? You know, if we change these variables, is that still the solution? That's another question we might ask. Okay, so the book states it a little bit differently. It says, is the optimal solution sensitive to changes in the input parameters? That's kind of what I'm saying. If we change that, you know, $8 per dozen for space rays and $5, does it change the solution, or is that still the solution? You know, is that still the solution? So, because parameter values used were only best estimates, you know, we have a dynamic environment that may cause change. Maybe, you know, a competitor enters the market, or, you know, maybe there's a shortage of these space rays and zappers, and we can charge more. What if analysis may provide additional economic and operational information? So the first thing we're going to analyze after a solution is we're going to look at something called the objective function coefficient. And we're going to use, I think we should use the GE45, GE60 as an example. So we just did that today, so you guys should all have that available. And the first thing we're going to talk about is the range of optimality. Okay? I want to show you that, and then we'll look at the words and definitions behind it, because I think it's easier to understand this after you see it in action. So I want you to go to the GE45, GE60s, and I guess this was part 3. Okay, and I want to solve it. All right, so I want you to resolve this. So click on Solver, click on Solve, and the screen that comes up that says, hey, we found a solution, all constraints and optimality conditions are satisfied. We haven't been doing this at this point, but over here on the right-hand side, you see it says Reports. You guys see that? Does that come up for you guys? I want you to click on, I'd like to see, along with the solution, something called a sensitivity report. And that's what we're going to learn to analyze today. Okay, so click on Sensitivity and click OK. Now you'll notice in your workbook that along with the GE45 and our Rifkin model, you have a new worksheet called Sensitivity Report 1. Let's click on that, and this is what we want to analyze. You guys get this? You guys see this report? All right, so the first thing we want to analyze is the objective function coefficients. And if you remember, we were making, I think it was maximize 50x1 plus 75x2s, right? This was our GE45, GE60. And you can see that because there's the two objective function coefficients. See the 50 and the 75? Okay, the range, what we're going to call this is the range, that's a crazy name, I know, range of optimality. Optimality, okay? And it's often abbreviated, and all abbreviated as RRO. ROO, so like root, range of optimality. Now I want you to listen to this. You don't have to write it this first time. And I'll show you what it is. Okay, the range of optimality is the range in which the objective function coefficient, if it's in that range, the solution will not change. Okay? So right now, for example, we're making $50
for every GE45 we make, right? We're making 50 bucks. So a question might be, well, what if we made 60 bucks, or what if we made 40 bucks? Would the solution change? Or would it still be make 80 and 53? Well, this tells us, you see this thing called the allowable increase and allowable decrease? If we take that 50 and the allowable increase is 0, so if we take that 50 and we add 0, and the allowable decrease is 25, so we decrease it by 25, 50 minus 25 is 25, 50 plus 0 is 50. The range of optimality for GE45s is 25 to 50. And what that's telling us is as long as I'm making between $25 and $50 for GE45s, this is the right solution. Make 80 of these and 53 of these. So if the price goes down by 10 bucks, we start making $10 profit, my mix will not change. What will change? Well, let's take a look at it. My profit, you're right. So let's go back to this. So what this is saying is the range of optimality for this, for GE45s, is anywhere between 25 and 50. So if I change this to 40 bucks, okay, now I'm no longer making $50 for every GE45, I'm making 40. Is 40 in my range of optimality? Is it in there? It is. Is my solution going to change? Let's try. I click Solver, Solve. It stayed 80 and 53. What did change though? My profit changed, of course, it went down. But the mix did not. And remember, that is my solution. This is what I'm deciding. Let's go down to $26. Okay, let's change this from 40 to 26. Is my mix going to change? If I solve it now, is 26 in that range, 25 to 50? It is. So will my mix change? No, it won't. Let's solve. Resolve. Yeah, it still says 80 and 53 is your best bet. How about if this goes down to 24? How about if this goes down to 24 and I resolve? Is 24 in my range of optimality? Is it? It isn't. So you think that mix is going to change? Yeah, it's going to change. Let's resolve. Now it's saying don't make any GE45s. They're not profitable enough. So as soon as that coefficient fell outside this range, it changed my solution. But anywhere in there, the solution was the same. I was testing the bottom end of it, but let's test the top end of it. So I'm going to go back to 50. I'm going to resolve, and it's going to take me back to 80 and 53. But it's telling me the allowable increase is nothing. Meaning if I go one more higher, if I just go a buck higher, what does it tell me is going to happen? Our mix is going to change because it's outside the range of optimality. So I put in 51, 51. I resolve. And now I'm making 130 and 20. I want you to try to envision what's happening here, okay? And this is the hard part, to envision what's happening here. But we'll go back to the definition. But think about it. You know, we looked at that range of feasibility, and we said, hey, the profit line is controlled by, you know, the functions. And we're saying we push out as far as we can, far as we can, far as we can, to the last point we touch. Well, if I change these coefficients, mathematically what it does is changes the slope of this line. So if it changes the slope a little bit, this is still the last point I touch, right? Or even this way, this is still the last point I touch. But it gets to a point where if it changes it this much, hey, now that's the new last solution I touch. Or if it goes this way, hey, now that's the remember, the extreme points are always an optimal solution. So what this is telling me is, I'm pretty close to another optimal solution. I'm only $1 away from another optimal solution, so maybe investigate that solution as well, because, hey, it's right in the ballpark, right? And what it's also telling me is, remember, these are just estimates. So your boss may say, I don't have a lot of faith in there. Your $50, that's a little optimistic for our profit for GE45. And you'll say, you know what? Even if it goes down to, we're only making $25 for every GE45, we're still doing the right thing. So you can give her a solution, and you can also say, here's where this solution is valid, right? You can say this is the solution, and even if these things change, this is still the solution. So I want you guys to help me look at the range of optimality for, I'm going to take that back to 50 and resolve just so we can do that, just so we can reset things. What's the range of optimality for GE60? So right now we're charging $75 for them. What is the range of optimality interpreted based off of that sensitivity report? What's the range of optimality? The allowable increase is 75 and the allowable decrease is 0. So what is the range?
75 to 150.
Very good. So the allowable increase is 75, so plus 75. The allowable decrease is 0, so 75 minus 0 is 75. 75 plus 75 is 150. So that's the ROO for GE60. So it's saying, if I go up another $10, another $20, another $30, another $40, another $70, still the right solution, right? As soon as I drop $1 off that profit, something else becomes optimal. Let's try it. Let's just, what if it? So if I change it to, I don't know, $125, is that in the range of optimality? It is. So if I resolve, still 80 and 53. If I go to 151, is that in the range of optimality? No. So if I resolve, we're going to see a change. How about if I go down to 74? Is that in the range of optimality? I resolve. Now, curiously enough, when I was playing around with GE45s and GE60s, there was only really 3 solutions that were coming up when I changed those numbers, right? One was 130-20, one was 80-53, and I can't remember what the hell the other one was. Do you remember? But there was only 3 that was coming up. Because what it was doing, if you can envision it, as we were playing around with that line, it was saying, in this range you're hitting this point. If you change the slope this much, you're hitting that point last. And if you change the slope this much, you're hitting this point last. So, that's what's happening behind the scenes. So the fact that, we assumed this with certainty, and I said, that's BS. We violate that assumption. We don't know those things for certain. Okay, we violate that, we know. But now this kind of helps us say, well, I know I don't know that perfectly, but I can tell you that, even if it's in this range, we're still right. We're still making the right amount, because that's what we're deciding ultimately. We're not deciding our profit, we're deciding what we can decide on, which is how many of product A and product B. Now, if we look at and I wanted to look at this last because it's ugly, but if we look at, the book's definition for range of optimality, it's kind of ugly, okay? But we might as well look at it. The range of optimality is, the optimal solution will remain unchanged as long as an objective function coefficient, that's what these are, lies within its range of optimality. That's what these are, right? That's what we saw. as long as there are no other changes in any other input parameters. So we have to say, well, only one thing's changing. When we change two things, well, then we kind of have to resolve. The value of the objective function will change if the coefficient multiplies a variable whose value is non-zero. What that is saying, I know it's a lot of words, but what it's saying is, hey, the profit will change. The solution doesn't change, but that objective function, which in this case is profit, will change because, well, it makes sense. I know I'm still making 80 and 53, but now I'm making 10 bucks a unit more, so obviously the profit's going to go up, right? It makes sense. It's kind of ugly there, right? It's kind of ugly there. I don't care that you memorize this definition, but I do care that you understand how to apply it, right? To understand what these things mean. Okay, it's 7 o'clock, and I think it's probably a good time to break. So this is our first break. Oh, we only get one break, so it's our first and last break. It's our only break. So take about 15 minutes, come back, and we'll continue. So we talked about range of optimality. We're going to move down, and we're going to talk about the constraints next. Okay, we're going to talk about what's cooking with the constraints. All right. Good. Okay, so part of sensitivity analysis is looking at the objective coefficient. So, basically the profit margins, like how much we're making, and seeing, what the values are, the range of optimality where this solution is good for. The other thing we can analyze or see how sensitive they are is the right-hand side. Okay, and this is the right-hand side of our constraints. So when we solve something, obviously these are the things that are holding us back. And as Dylan pointed out, as a manager, you're going to ask, well, what's holding us back? Can we make more money? Can we minimize our investment even more? Whatever it might be. And typically that comes down to analyzing the constraints that are what's called binding, and then seeing what can we do to change that. And if we do change it, what happens? So we're going to look at something called the shadow price. All right. So once again, what I'd rather do than talk about it on the slides is let's see this. Okay, so so let's go to Excel and let's look at this one. And first off, I want you to tell me what's holding me back. Just before I look at the sensitivity report, what's holding me back? What do I have no more of? I'm using all of, if you want, Will. Caleb? Go ahead.
I was going to say time.
Yeah, assembly hours, right? We have 240, and we're using 240. What else? Inspection hours. We have 80, and we're using 80. All right, so my question is, all right, I'm using all of that. What would I do with more? How would that affect my solution if I got more, or if I lost them? Well, we can analyze that through the sensitivity report. Okay, and let's click on the sensitivity report. And at first we analyzed everything up here. Well, we didn't analyze everything, because we still have to talk about this, but we'll get to that next. But down here is where we see the production hours. So let's resolve and get a new sensitivity report, because I want to make sure that matches. So I click solve. Solve our final solution. I'm going to keep it. Okay. Oops, I forgot to keep the solution. So solve. I'm going to keep the sensitivity report. Okay, so I'm going to look at 2, make sure everything matches. All right. So let's look at inspection hours. All right. So right now, I have 80 inspection hours, and I'm using all 80. That has what we call a shadow price. Okay, see that shadow price? It says 100. This column says 100. Here's what the shadow price is telling us. For every change to the right-hand side of that constraint, the objective function value will change by the shadow price amount. Okay, so let's listen to that again. If I increase that 80 to 81, the objective function value is going to also increase by 100. what is the objective function value? In this case, it's profit. If I get an extra hour, my profit's going to go up $100. If I lose an hour, guess what's going to happen to my profit? It's going to go down $100. Okay, that's what the shadow price is telling us. It's saying, hey, I know this thing is binding, meaning I'm using all of it. Okay, it's a binding constraint. It's something that's holding me back. It's binding me, right? And what the shadow price tells me, and you notice, production hours doesn't have a shadow price because, hell, I have 300 of them, and I'm using only 266. So, who cares if I get an extra hour or lose an extra hour? It doesn't change anything, yes? But inspection hours does matter. So let's try it. Let's say we go up to, it tells us if we get an extra hour, our profit's going to go up $100. So let's try it. Let's change this from 80 to 81 and resolve. What did the shadow or the sensitivity report tell me is going to happen? This profit should go up to 8,100. Let's solve it and see. It did. Let's go up to 82. I'm going to click solve. It's going to go up another $100. Let's go up to 90. So I got 90 production hours, and I resolve. It's going to go up. Well, I got 10 extra hours. It should go up. It didn't though. Let's see why. Okay, should have went up. We thought what? Thought it would go up $1,000, didn't we? Well, let's look at that sensitivity report, because there's something that goes along with the shadow price, and it's another range deal. Okay, you see this allowable increase and allowable decrease? It says the right-hand side is 80. The allowable increase is 6.25 hours. So we're going to have to do that offset again. So we have 80 hours of inspection time. The allowable increase is 6.25. The allowable decrease is 20. So minus 20, that goes from 60 to 86.25. This new range is called the range of feasibility. I know, new ugly term, and obviously often abbreviated as ROF, range of feasibility. And what the range of feasibility tells us is the range that shadow price is valid for. It says for every additional hour we get, we'll get $100. But we just can't keep adding inspection hours and getting $100 every time, because guess what? After we add so many, guess what? Something else is going to be holding us back, right? So the range of feasibility tells us where that shadow price is valid for. It says I can get an extra $100 for an additional, every additional hour up to an additional 6.25 hours. As well, I'll lose $100 for every hour that I lose, down to 60 hours. After that, something else is becoming binding. Does that make sense? So let's go back to the beginning. Let's change this to 80 and resolve, just to set it where it is. So let's test that out. If I go up to 86, it says, okay, that's in the range of feasibility. So the shadow price was 100. So I should get what? When I go up to 86, the profit should go from 8,000 to 8,600. So let's see if that happens. It does. But if I go up to 80, let's go up to 90. 90 is not in there, right? 90 is outside the range of feasibility. And I resolve, and I didn't get that extra 1,000. I didn't get that $100 for every 10 unit, for all 10 units. I only got 625, because guess what? As I did that, production hours became binding. You see that? Now that's the thing that's holding me back. Before I had plenty of production hours, right? But as I kept adding inspection hours, I kept using production hours, my surplus production hours, and now
That's the thing that's holding me back as well. So if I resolve it right now, I guarantee you production hours, remember it had a shadow price of 0? If I resolve it under this current formulation and keep the sensitivity report, I'll see that now production hours do have a shadow price because, hey, we have 300, we're using all 300. Now it's telling me, hey, if you add some more production hours, I'll give you $18.75, for every extra production hour. So as a manager, what you have to ask yourself, right? In that previous situation, inspection hours, every extra inspection hour was $100, right? If I can get an extra inspection hour for $50, should I do it? It adds $100 to profit. Should I do it? If I have to pay overtime for $50 an hour, should I do it? Sure. If I have to pay overtime at $150 an hour, should I do it? Probably not. Okay. Probably not necessarily. So you see how that allows me to ask the question, all right, what's holding me back? And if I get more of it, or if I lose some of it, what happens to this thing I'm trying to optimize, right? It allows me as a manager to delve deeper into the solution. Not only is this a solution, but how could I increase the solution? How could I make more, right? Or what would hurt me if I lose this? What hurts me? All right. So let's look at the slides, okay? I'm going to try to understand this through the slides. So I try to show it first and then go to the slides. I think that helps. So it says, the shadow price is this. Assuming there are no other changes to the input parameters, the shadow price represents the change to the objective function value per unit increase to a right-hand side of constraint is called the shadow price. Basically, it's saying if I increase that right-hand side by 1 unit, the objective function value, which in this case is profit, increases by the shadow price. If I decrease it by 1 unit, the objective function value decreases by that shadow price. Further, okay, and this is what's happening, okay, just if you want to visualize it. What's happening when we get more hours, like this is the space ray and zapper. If I get more plastic, remember that was the plastic constraint, that yellow line? If I get more plastic, okay, what happens is, well, geez, I get more plastic, so that line gets pushed out, and now all this area here that was infeasible, all this area here, because I have more plastic, becomes feasible, and what it allows me to do is push out the profit line further. So in this case, it looked like the shadow price, was $60. For every plastic I got an extra $60. So that's what's happening. If I relax constraints, obviously I can further things. If I add more constraints, I constrict myself more. It hurts my optimal value. Okay. The thing that is married to the shadow price is the range of feasibility. I talked about that. And the range of feasibility basically tells me the range where the shadow price is valid. Okay, so assuming there are no other changes to the input parameters, the range of feasibility is the range of values for a right-hand side of a constraint in which the shadow price for the constraints remain unchanged. Basically, it's saying where that shadow price is valid. Because eventually, we can't push it out, we keep pushing it out, something else becomes binding. Okay. I'll come back to this slide. Questions on that? All right, let's go back to this original formulation. So I'm going to put this back at 80. I'm going to resolve this deal. But let's say, let's say GE45s become super profitable. Let's put them at 250 instead of 50. Okay. And I'm going to resolve. I'm making $250 for every GE45 instead of 50. So solver doesn't care. It's going to push production to whatever is the best. So you see, it pushes all the production to GE45s. So I'm going to resolve that, and I'm going to keep the sensitivity report, this new sensitivity report. Okay. So if you have this situation, if your optimal solution says make 150 GE45s and no GE60s, what question might you ask as a manager? And that's the optimal solution, that's fine. But what might you ask as a manager? You might want to know what, Dylan?
Why isn't the G60 profitable?
Very good. Why aren't we making them, right? Why is it not profitable to make them? How much more profitable would they have to become for it to be profitable for me to make them, right? How much more would we have to make per unit before I should start making them? Well, the sensitivity report tells me that, okay? We're going to go back up the top again. And you'll see a value called reduced cost. You guys see reduced cost? We don't have reduced cost for the GE45s. It's a 0 because we're making them, right? We're making 150 of them, so we don't have a reduced cost. But for the thing we're not making, the GE60s, we see a negative 175. What that's telling me is two things. Okay, it's telling me two things. It really says two things. It says if I say the hell with this and I make a GE60, I force a production of 1 unit for GE60, my profit is going to be down by 175. My profit's going to go down by, you know what I mean? If I say the hell with it, I still want to make a GE60, fine, you can do that, but it's going to cost you, your optimal profit's going to go down by the reduced cost. It's also telling me if I want to start making GE60s, I better reduce the cost that I put into them, and hence the profit, by 175. And then they'll start becoming part of the solution. So I'd have to increase the profit on them by $175 before it starts becoming part of the solution. So let's look. Right now I'm making 75. What did I say? I had to make it by 175, is that what I said? So let's go up to 100, so 75 plus, let's do 150. Let's say we start making 225. So I increase their profitability by $150. Is that going to be enough? According to reduced cost, it's not. Let's try it. Solve, solve. I'm still not making it. Let's go up to 251. Am I going to start making them now? Went from 75 to 251. That's a change of $176. They're going to be profitable enough now. Click solve. And now you see we start making those things again. So the reduced cost, if we have it, okay, not always will we have it. When we're making something, we don't have a reduced cost. Reduced cost tells us two things. It says if we want to ignore it, ignore solver and say, start making that because we want to have some GE60s out there in the market, that's fine. But for every unit you make, you're taking resources away from the more profitable GE45, and your profit is going to go down by this amount per unit. Okay, that's one thing it tells me. The second thing it tells me is if you want to start making this product, you better charge at least this much more. Or your profit better go up by the negative of this, which is positive 175. Now this is a terrible, awful definition. So I wanted to go through this first because the definition is just horrendous. But remember, you don't have to memorize anything in this class. It says this. If I can find it. Oh, there it is. It says, assuming there are no other changes to the input parameters, and you notice all these things have that assumption in there, the reduced cost for a variable that has a value of 0 at the optimal solution, meaning we're not making any, is this. The negative of the objective coefficient increase of the variable necessary for the variable to be positive in the optimal solution. So remember the reduced cost was negative 175? the negative of negative 175 is positive 175. That's the increase necessary for us to start making them. That was step one. Alternatively, it is the change in the objective value per unit increase of xj. So if I start making them, my profit is going to go down by $175 per unit. Okay, that's what reduced cost is telling me. Okay? So we only have that, and there's a rule associated with that called the rule of complementary slackness. And it says at the optimal solution, either the value of a variable is zero, either we're making none of them, or its reduced cost is zero. And we saw that in our sensitivity report. Either the reduced cost is zero or the final value is zero. It's called the rule of complementary slackness. I know you're getting tired. One last concept, and then we're going to apply it to a problem, okay? One last concept. I lied, two last concepts. And this one's a tough one as well. Now, we think about shadow prices, and even when I talk about shadow price, I kind of misinterpret. When we figured out these profit coefficients, like 50 and 75 for these GE45s and GE60s, how would my managerial accountant have figured that out? How would they figure out that I make $50 for every GE45 and $75 for every GE60? What would they have done? Like, how would they go about that, projecting that I make 75 and 50? What would they have done? How do you project profit for a product? In the simplest terms, what would you do?
Look at the past.
Okay. But even simpler than that. I'm not going to look at forecasting. I know what I sell it for, right? Sell it for, let's say, $100. How do I figure out profit? What do I subtract out to get profit?
Like your manufacturing cost.
Yeah, my material, my time, right? So think about that. All those things, material and time, are baked in here, aren't they? Aren't they part of that coefficient? When we figured that out, someone included that cost in there, right? And we call that an included cost. Okay, those are called included costs because in 99 out of 100 times, these costs are included costs, right? They're factored in. So when these costs are included costs, the shadow price doesn't just represent the value you should be willing to pay for an extra unit of that resource. Like we were saying, $100 for every inspection hour. It represents the premium above what we normally pay that we should be willing to pay for every inspection hour. So if we normally pay $10 for every inspection hour on average, right? That $10 is already factored into these profit coefficients. It's already counted in there. So that $100 represents the premium above that normal cost that we should be willing to pay. Does that make sense at all? I know that's kind of a far reach, but it's called an included cost. If I'm doing my business right, 9 times out of 10, those are going to be included costs. We're trying to account for those costs. There can be other sunk costs, but we try to include everything in those profit coefficients. Our overhead, our manufacturing, all that stuff we try to put in there. Okay. All right, so here's what I'd like to do. I know we went through a lot, but I would still like us to try to do one together. So before we leave here. So out on Blackboard, under Chapter 2, under Chapter 2 examples, did one of these last week, let's do another. Let's do the third one. So I not only want you to set this up and solve it, but after you solve it, I want you to keep the solution, and I I want you to analyze the sensitivity report, okay, as much as you can, okay? Tell me what's binding, what's holding us back, what the solution's good for. Can you guys see that? It's on Blackboard if you can't see up here. It's under chapter 2. So take like 10 minutes, try to do this on your own, then we'll do it together. Okay, I'd like you guys to help me set this up. So I'm going to go into Excel, and I want to make a copy of my GE45, GE60, and I'll call it golf. So what are we making here? What are our decision variables in this case? What do we have, Eric?
So standard and deluxe.
All right, so standard and deluxe. And we'll start with 1 and 1. And we're maximizing profit, yes? And what is it? What are the coefficients? Standard bag we make how much, and deluxe bag we make how much? 10 and 9? So relatively close. What are our constraints? What are holding us back here? I think as we look there, things that go in the production process hold us back. So one of the first things is cutting and dyeing time. Is that right? Okay, so we'll call it C and D. And what are our coefficients for cutting and dyeing? 42 and 60? And that's in minutes, I assume? And how many hours or minutes do we have for cutting and dyeing?
37,000.
What do we have?
37,800.
37,000, that's in minutes,
That's in
right?
minutes.
Okay. So in hours, that's what, divided by 60? What do we have there? Okay. Also, things holding us back, sewing. So we'll change this next one to sewing. And for sewing, our coefficients are what?
30 and 50.
What is it?
30 and 50.
30 and 50, thank you, Noah. And that's in minutes, so how many minutes do we have, Noah?
36,000.
Okay. We also have finishing time, so let's go here, type in finishing. Our coefficients for finishing are what? 60 and 40. That's in minutes, I assume. And how many minutes do we have?
42,480.
42,480. And the last one, we have 4 constraints, right? Inspection. And what are the coefficients here? 6 and 15? And how much of those do we have? Minutes. Inspection time. What's that?
8,100.
8,100. Does all look right? So I'm going to change my decision variables, make sure everything down here changes appropriately. I need to tell solver about my objective function. That looks good. We're trying to maximize that by changing C2, D2. I'm going to delete my constraints and start over. Try to delete my constraints. There we go. Okay. I'm going to add all 4 of them at once, so I'm going to say add E6 through E9 is less than or equal to G6 through G9. Okay, non-negativity, good. I'm going to click solve. And this time I'm going to keep my sensitivity report. Okay, so our answer is 540 and 252. Is that what you guys got? Seem right? All right. And it makes us a profit of, looks like $7 grand, okay? Now, just looking at this solution, what is holding us back? What is binding? What is binding? What's holding us back? What are we using all of? Just looking at this, not even looking at the sensitivity report. Yeah, we're looking at cutting and dyeing, right? That looks like we're using all of that. And it looks like we're using all our finishing time. It looks like we have surplus or slack sewing time and surplus or slack finishing time. Let's go to the sensitivity report. What's the range of optimality for the, so we charge right now, we're charging, or our profit is $10 for every standard bracket. What's the range of optimality for it? So that was just an estimate, $10 for every standard bracket. What's the range of optimality for the standard brackets? Meaning the solution won't change, and we'll still make 540 and 252. We'll take that 10 and we subtract off 3.7, it gives us 6.3, add 3.5. So anywhere between 6.3 and 13.7, hey, we're good. That's the right mix, yes? Same thing with deluxe. We take that 9, and if we subtract out 2.33, we get 6.67. Add in 5.28, we get 14.28. Anywhere in that range, our solution doesn't change. Now, if we look down here at our cutting and dyeing and finishing, interpret, I don't know, let's interpret finishing time. That's holding me back for sure, right? I have 42,000 minutes. I'm using all 42,000 minutes. If I can get an extra minute, what would happen to my profit? It would increase by what? Not 11%. 11 cents. 11 and a half cents. If I get 2 extra minutes, it would go up to roughly 22, 23 cents, yes? Every extra minute I get, my profit goes up 11 and a half cents. Okay? Can I do that forever and ever and ever? Can I just keep adding minutes and keep adding to my profit? 11 cents to my profit? No. Why not? What's the allowable increase or the range of feasibility for that shadow price? The allowable increase is 11,520. So I can add up to an extra 11,520 minutes. And for each of those 11,520 minutes, I know I'm going to get an extra 11 cents. But beyond that, once I start adding more minutes than that, something else is becoming binding, right? Something else is holding me back. At this point, this is helping release my thing. If we look at, one that has slack, you'll see like sewing time, I used 28.8, I had 36,000 minutes. The shadow price is 0, which means if we get an extra unit of sewing time, if we get an extra sewing minute, does that help us at all? Our profit stays 0, right? If we lose a minute of sewing time, does that change my profit? No, because I'm not using the minutes I have, right? But if we look at the allowable decrease, it's 7,200. What's the difference between here and here? 7,200. Because once I fall below that 28.8, hey, guess what? Now that's binding. Now that's going to hurt, right? So what we're doing here is saying, here's the solution, but here's additional information that goes around that. So it tells us, how valid is the solution? What's holding me back? What would happen if I release it? So I can do what if analysis. And the other great thing is beyond interpreting the sensitivity report, I'm lucky that it's in Excel, because all I really have to do is try it. If I say I'm making 11 bucks for every standard bracket, hey, that was in the range of optimality, but let's just see. So if I go to data, solve, saying my solution won't change, let's see. It didn't change. My profit changed, my solution didn't change. It told me that if I got an extra finishing minute, so it went from 42,480 to 42,481, my profit is going to go up by 11 cents. Now, It's 11 cents, it just. Oops. 11.5 cents, exactly what my shadow price was. Okay? So this is how these things work together. So really we're still in chapter 2. The homework I'm giving you for next week is still in chapter 2, but it's going to ask you to analyze the sensitivity report along with it. So you'll see some of the questions are follow-ons from this week. Like last week we did 2A, and then B and C started talking about the sensitivity report, and we pushed off on that. We'll ask you to analyze that this week. So let's go to the homework here. So week 3, I would like you to do on pages 101 and 110 of your course text. You already did 2A, I'd like you to do B and C. You already did 3A, I'd like you to do 3B and C. Now if you want to just cut to the chase and say, hey, I want to prove that I know how to do this, if you can do 26 and 27, it's a bakery example. It's kind of a silly example, running like a little bakery, like maybe like the Laughlin Town Bakery or something like that, and we're deciding on how many pies to make, okay? But it's a good problem because it deals with range of optimality, deals with shadow price, deals with range of feasibility, and it deals with reduced cost. So it has all those things factored in those two problems, 26 and 27. So if you can do that, you understand it, then you know you should feel pretty comfortable with this material, that you understand this material. Okay. What questions might you have? Okay, well, be safe on your way home, and I will see you all next week.